Hi guys, in this tutorial I'm going to solve question number 6, Mechanics, Jan 2019. Train travels for a total time 270 seconds along a straight horizontal track between two stations A and B. The train started from rest at A and moved with constant acceleration for 60 seconds until it reaches speed value V. The train then travels at constant speed before it moved with a constant deceleration for 30 seconds coming to rest at station B. Sketch the speed time graph for the journey of the train between the two stations A and B. This is normal question to sketch the velocity time graph or speed time graph for the train. It's represented trapezium. The train starts from rest. The first part accelerating, start from rest. So this part accelerates, then move with constant velocity. So the acceleration is equal to 0, then start to decelerate. The time taken for acceleration is more than the time taken for deceleration. It's better to show that in your graph. You have to show the time and you have to show the velocity. If we start again, the deceleration time is 30 and the total time 270. The total time is 270 and this part will be 240 because it's given the deceleration time is 30 seconds and accelerating the time is 60 and velocity up is V. Asked to sketch the velocity time graph for the two stations. Given that the distance between two stations is 4.5 kilometer, will be 4500 meter. As we know, the distance between the two stations represents the area under the curve and the x-axis. So the area of trapezium is equal to 4500. By solving this equation, you can find the value of V. As we know, the area of trapezium is equal to half A plus B into height, where is A and B are parallel. So by using this part, if we subtract 240 minus 60 to get the length of time, where is the train moving with constant acceleration, is 240 minus 60, so the answer is 180. So area of trapezium is half, A is 270, B is 180, and the height is V is equal to 4500. By solving this equation, 270 plus 180 is equal to 450 times half times V is equal 4500. So 4500 divided by half of 450. So the answer of V will be 20. So now velocity is equal to 20. Find the value of V. This is part B. Part C, find how long it takes the train to travel from station A to the point that exactly halfway between the two stations. Halfway between the two stations, let's say at this part. So the time taken is T. So the part left between will be T minus 60, and this part will be T minus 60. So I will get the area of this trapezium. The area of this trapezium is equal to half distance of 4500. Again, repeat again, area of trapezium is half A and B. A is T and B is T minus 60 multiplied by the height, which is 20, is equal to the half distance between the two stations, which is 4500 divided by 2. So the answer will be 2250. Simplify. Half of 20 is 10. T is 2T minus 60 is equal to 250 divided by 10. So 2t minus 60 is equal to 225. So 2t is equal to 225 plus 60. Then divided by 2, t equals 225 plus 60 is equal divided by 2. So the answer will be 142.5. So the time taken to be a half distance in between 142.5 seconds. This is part C. The train is traveling at speed force v at time t1 and time t2. Force v, I will show that on the graph when the velocity will be fourth of 20, like exactly to be 5. This is the fourth. There is a timing here, t1, and another time here is t2. Asked to get the values of the time. By using mechanics, you can find the acceleration for this part and apply it for this part. We can get first the acceleration, which is v minus u over t. Acceleration is, the final is 20, initial is 0, and the time taken is 60. If you simplify, so the answer is third. I will repeat it again, but in case if the velocity is 5, whereas 5 is fourth of 20, fourth of 20 is 5. We already have the acceleration is third, equal to the final velocity is 5, initial is 0, and the time taken is t. Use cross multiplication, you can find the time is 50. Or we can use similarity to solve this question. How? It's given the velocity is fourth the velocity. So the ratio here 1 to 4. So the ratio of the time 1 to 4. So the time here is fourth of 60. So the answer direct is 50. By the same way, we can find the second time. We can use deceleration for this part. I will get the deceleration by using the first method, by finding the deceleration. Acceleration is v minus u over t. So the deceleration, the final velocity is 0, the initial is 20, the time taken is 30. So the deceleration in this part, negative 2 over 3. Apply it again. The deceleration is negative 2 over 3, is final velocity is 0, initial velocity is 5, divided by the time t. Cross multiplication and the solve equation, you can get t is 7.5. But he asked to get the value of t will be the total time is 270 minus 7.5. The total time is 270 minus 7.5. So the final answer is 262.5. You can also use similarity. How? You ask to get the fourth, 1 to 4, so 1 to 4. The velocity is 1, 4, the time is 1, 4. So I will get the fourth of 30, which is 30 divided by 4. If you divide 30 divided by 4, you will get 7.5. So the time is 262. How to get 262? The time is 270 minus 7.5. You will get your answer 262.5. This is the timing for both. This is T1 and this is T2. So T2 is equal to 262.5 and T1 is equal to 50. He asked to find the value of T1 and T2. That's it. Thank you.